Have you ever wondered if we humans still have ape brains? A provocative question that stirs curiosity and sets the stage for our exploration today. We're about to embark on a thrilling journey, delving deep into the fascinating world of brain evolution. Tracing our steps back through millions of years, we'll unravel the mysteries of our minds. Do our brains still bear the marks of our primate ancestors? Stay tuned to explore the fascinating journey of the evolution of the human brain. Before we delve into our main question, let's understand the basics of brain evolution. The story of brain evolution begins millions of years ago, when the first organisms with nervous systems emerged. These primitive beings had simple nerve nets, but through a process known as natural selection, these systems gradually became more complex. Natural selection, the driving force behind evolution, operates on a simple principle: survival of the fittest. Organisms with traits that increase their chances of survival are more likely to reproduce, passing these advantageous traits to their offspring. Over countless generations, these beneficial traits become more prevalent, shaping the species. When it comes to brain evolution, the principle is the same. Over time, species with more advanced brains had a better chance of survival. These brains allowed them to adapt to changing environments, find food more efficiently, and avoid predators. Consequently, these species flourished, and their advanced brains became a common feature of their descendants. But here's where it gets interesting. Not all brains evolved in the same way or at the same rate. For example, the brains of birds developed exceptional spatial memory and problem-solving abilities, enabling them to navigate vast distances during migration. Meanwhile, dolphins evolved large and complex brains that support sophisticated social structures and communication systems. And what about us, humans? Well, our brains took a unique evolutionary path. They're not the biggest in the animal kingdom, but they are the most complex. They've evolved to support advanced cognitive functions, such as abstract thinking, language, and self-awareness. It's also important to note that brain evolution doesn't imply a linear progression towards a perfect brain. Instead, it's a branching tree with different species evolving different brain structures and capabilities based on their specific needs and environments. With this foundation, we can now delve deeper into the evolution of the human brain. So, how did the human brain evolve from the ape brain? Let's take a step back, about 7 million years ago, when our ancestors first diverged from those of chimpanzees, our closest living relatives. The human brain's evolution was not a straightforward path, but rather a complex process marked by a series of significant stages. The first of these stages was marked by the development of bipedalism, the ability to walk on two legs. This change in locomotion freed up our hands, allowing our ancestors to use tools which in turn stimulated brain development. Around 2 million years ago, a dramatic increase in brain size occurred in the genus Homo. The brain nearly doubled in size from the chimpanzee-like brain of our early ancestors to the far larger and more complex brain of Homo erectus. This dramatic increase in brain size is often associated with the development of more complex tools and the control of fire, activities that required and promoted cognitive development. However, size isn't everything. The human brain is not just larger, but also structurally different from the ape brain. The most significant difference lies in the neocortex, the part of the brain responsible for higher-order functions like conscious thought, spatial reasoning, and language. In humans, the neocortex is highly expanded and convoluted, allowing for a greater number of neurons and connections. One of the most interesting changes in our brain's evolution is the development of the prefrontal cortex, the area of the brain responsible for complex cognitive behavior, decision-making, and moderating social behavior. The prefrontal cortex in humans is much larger and more complex than in any other primate. This development has allowed us to engage in advanced problem-solving, introspection, and the creation of complex social structures. Let's not forget about language. The evolution of language has had a profound impact on the human brain. Areas such as Broca's and Wernicke's, associated with speech production and comprehension, are unique to humans. The development of language has not only allowed us to communicate more complex ideas, but has also shaped our brains in a way that is distinct from our ape ancestors. Yet, despite these differences, it's essential to remember that we share about 98% of our DNA with chimpanzees. Many of the fundamental structures and functions of our brains remain remarkably similar to those of our primate cousins. So, we've seen how our brains have evolved, but does that mean we no longer have ape brains? Well, that's a question for another scene. Stay tuned. So, do we still have ape brains? This question might sound a bit perplexing, but it's a valid point of inquiry when we dive into the depths of our evolutionary history. We share a common ancestor with apes, a fact that's well established in the scientific community. But does that mean our brains are simply an advanced version of an ape's? To answer that, let's explore some of the similarities and differences between the human brain and the ape brain. First, similarities. Both humans and apes have highly developed frontal lobes compared to other animals. This region of the brain is responsible for complex cognitive processes like decision-making, problem-solving, and planning. So in this regard, we do share some commonalities with our primate cousins. However, the differences are significant and fascinating. The human brain is 3 times larger than the ape brain, and this is not just about size. This increased mass provides us with more neural real estate, allowing for the development of advanced cognitive abilities. In essence, it's like comparing a small town to a bustling metropolis. Moreover, our brain structure has evolved to support language, abstract thought, and introspection, capabilities that apes, as far as we know, do not possess. Also, the human brain has a more developed prefrontal cortex, the area responsible for executive functions like self-control, strategic thinking, and empathy. Let's consider another unique aspect of the human brain, its plasticity. Our brains have an extraordinary ability to adapt and change throughout our lifetime, a trait not observed in apes to the same degree. This plasticity enables us to learn new skills, adapt to new environments, and even recover from brain injuries. So, to circle back to our initial question, do we still have ape brains? The answer is a nuanced no. While we share a common ancestor with apes and have some similar brain structures, the human brain has evolved significantly. It has developed unique features and capabilities that set us apart not just from apes, but from all other species on Earth. So while we have evolved from apes, our brains have taken a unique evolutionary path. Let's recap what we have learned today. We've journeyed through the fascinating landscape of evolution, specifically focusing on our brains, the intricate organ that sets us apart from our primate relatives. We started with the basics of brain evolution. All living creatures on this planet have a common ancestor, a simple life form from which we all evolved. The brain, like any other organ, has been subject to this evolutionary process. Over millions of years, it has gradually evolved from a simple nerve net in primitive animals to the complex structure we see in humans today. Our journey then took us from ape to human, tracing the evolution of our own brains. Around 7 million years ago, our ancestors branched off from the great apes, embarking on a unique evolutionary path. This journey was not a straight line but rather a winding road, with many twists and turns. Our brains have evolved to be larger and more complex than those of our closest relatives, the great apes, allowing us to develop advanced cognitive abilities such as language, abstract thinking, and problem solving. The question we then grappled with was, do we still have ape brains? It's a provocative question that draws on our understanding of both human and primate evolution. The answer is both yes and no. Yes, in the sense that we share a common ancestor with the great apes, and therefore, our brains retain some features that reflect this shared heritage. But also, no, in the sense that our brains have evolved along a different path, leading to unique human characteristics. Our brains are larger, especially the neocortex, the part responsible for our higher cognitive functions. We have a more developed prefrontal cortex, which plays a crucial role in decision-making, planning, and social behavior. And our brains are more lateralized, with the 2 hemispheres specializing in different functions. While our evolutionary journey started with our ape ancestors, our brains have taken a unique path, making us uniquely human. Remember, evolution is a continuous process, and who knows what's next in the evolution of the human brain.